Okay, believe it or not, this is the last video for our chapter, but we've got several class periods left, and that's because this chapter really lends itself to practice. You need to practice the concepts. And so I'm going to show you some things today that are just basics, and then it's going to be up to all of us to be practicing before the test next week. Now, I'm going to do this a little bit backwards because I'm going to show you several visual examples and throw out some terms first, and then I'm going to explain the terms later. Hopefully there's a little method to my madness. You'll start to familiarize yourself with what some of these terms look like visually, and then when you start to practice them, hopefully that information will become a little bit more embedded into your memories. You'll actually learn it. So here we go. First of all, Mr. Woodard ended up the last video talking about experimental design. Now you have all this data, you have all these numbers. What do you do with it? And that's what today is all about, and that's organizing the data. So first of all, the first thing that you do is you take all your data and you put it in what's called a frequency distribution. And that is literally just listing out all the data from smallest number to greatest number. So here, if I have my data sets here, 1 is my lowest number, 15 is my highest, and I just put everything in order. That's a frequency distribution. Now, we can take all those numbers and put them into a bar graph called a histogram. Now, if you look at the original PowerPoint, Mr. Woodard has a bunch of histograms in there from a survey he did with students a year or two ago. Now, I've whittled that down for our purposes so we don't have all those graphs in there. Mr. Woodard might do that with his classes again this year. I'm not sure. He might show you those other graphs. But I'm going to just show you again the basics for our time here. So you can see here, here's a histogram of how many pairs of shoes his classes owned. And you can see how it's kind of weighted more this direction. There's more responses over on the left side of this graph, okay? Now on this one with cumulative GPA, you can see here, the middle is over here, more responses are over there. Again, bear with me here. Now on shoe size, you can see that the middle of the graph is somewhere in this area, and we're really close with most of our responses being in here. We're really close to the middle. What we're looking for, if we were to do a huge experiment, especially with like standardized tests, they love what's called the normal curve on a standardized test. And this middle part right here, where everything kind of meets perfectly, and what the three things that meet perfectly are what's called the mean, median, and mode. If you have a normal curve, 68.3% of the population that you've studied will fall within one standard deviation of the average, the mean. Again, I haven't talked about mean, median, and mode. I haven't talked about standard deviation. Just bear with me. Know these numbers. The AP exam loves these numbers, okay? 95.5% will fall within 2 standard deviations, and 99.7% will fall within 3 standard deviations if you have a perfect, symmetrical, normal curve, okay? Again, AP loves to ask about these percentages, and they'll generally do it without the decimal. It'll be 68, 95, or 99, okay? All right. Now, here we have a slide, and you can see here the blue line would be a perfect normal curve. Again, you can see that we're off to the right just a little bit. And then if I go back to the pairs of shoes, remember, there's more weight down here. So if I'm going to draw the curve for this one, you'll notice that it goes like this, and then it has this long tail that goes this direction. Okay? This is a graph that's skewed right. The tail is longer to the right, so it's skewed right. With this great little mnemonic device, one of the math teachers came up with this. I think it was TR, I'm not sure. They said, look down at your feet. And if you look down at your right foot, your big toe is over here, and then the rest of your foot kind of drifts off this way, and then your pinky's down here. So that's a good way to remember skewed right and skewed left, because a lot of people want to say this is skewed left because all the data is over here. Well, that's wrong. you want to look at the size of the tail or think in terms of a foot. Your big toe is over here, and then the rest of your foot goes over here for your right foot. If it was a left skewed graph, then if you look down at your left foot, the big toe would be over in this area and the tail would go the other way. Okay, now again, I know I'm talking a lot about skewed and normal, and so let's start looking at the precise terms. In a normal distribution, you can see here we have our percentages again. The standard deviation really is showing us how spread out our numbers are. Okay, and you can see here it shows the average difference between a score and the mean. I like thinking in terms of how spread out our data sets are. If everything is perfectly symmetrical, then you'll get these percentages. And again, we're going to work with standard deviation in class. So I just want you to know the terms for this video and definitely, again, know those percentages. All right. Now, mean, median, mode, and range. The range is the difference between the highest and lowest score. The median, the mean is just the average. The median is the exact middle score, and the mode is the most frequent score. Let's look at this with a very simple frequency distribution. Okay? If I'm looking at this frequency distribution, set A, then I see that I have 5 data sets. Set B also has 5. I take the average of both of these. If I go average of set A, 1 plus 1 plus 1 plus 7 plus 10, okay, I get 20. I divide that by 5, I get an average of 4. You'll notice set B has the exact same average. The mean, the average, is 4 for both of those sets. However, the median is different. Literally the middle number in the frequency distribution. Here it's 1, here it's 5. What about the mode? Which number pops up the most often? Well, here it's the number 1. Here it's the number 5. Okay? So and range, the range for set A is 9. The largest number minus the smallest number. Here it's 5, 6 minus 1, 5. So you can see when you start digging into the numbers that the mean, the average, doesn't tell you the whole story, because the average for those two data sets is exactly the same. But you start asking yourself, well, what is the high, what is the low? Which number appears the most often? And if you were to convert that into a bar graph and then do your curve, you can see that the curves would be different as well. Okay, again, giving you a lot of basics, we're going to do a lot of practice. Now, one of the main, those are all what are called descriptive statistics. They describe the numbers. One of the main inferential statistics, something that we can infer from our numbers, is what's called p-value. And there's a video here that we'll show in class, or you can watch on your own, that explains this a little bit more. P-value is telling us the lower the p-value, the better, because the lower the p-value, that means that the results are not likely due to chance. Mr. Woodard kept talking about one thing causing another. If we're looking at one thing causing another, we want to eliminate any other variable that created what appears to be a connection, a cause and effect. A low p-value tells us there's not another connection. It is one thing causing another, if you will. Okay. Now, one of my favorite stories on p-value, this is how important p-value is in the psych world. P-value, actually, that 0.05 is what gives us what's called statistical significance. If you have a p-value that's larger than 0.05, you may have to redo your research. I was listening to a psychologist that was doing her PhD, and sure enough, her p-value ended up at 0.06 in change. It was just slightly higher than 0.05. She didn't have to redo the entire experiment, but she did have to go back in, dig into the numbers, and start sifting through and making sure that she had reliable information. Okay, that 0.05 is another number you want to remember, because that is what tells us that we have statistical significance. Okay? Now, I've talked about 10 minutes. I'm going to leave it up to Mr. Woodard and myself to talk about the very last slide in ethics and research on our own in class. Again, I just want to remind everyone, I'm giving you basics today. Now let's go practice and talk more about this.